You might continue them around because I think I give you guys too much. So what you want to do, this was from the Manucellus, so I thought it was good. I might move it down right here, Alicia, because I'm going to need the Elmo. So what you might, someone still need one?
Nikki's not here right now. Jen does.
Jen.
I think Leah and
So there were no more?
You got 2 months?
Well, that's weird. Oh, maybe I still have them.
You can keep it behind.
Well, yeah. Put, do you guys need two?
Yes.
On your side? Here you go, Jen. Give them. And then put that, and you want to put Nicole's name on that? That'll be good. These are from the Manucellus book, and I wanted to give you, I think what's really hard about fungus is all the terminology of, oh my gosh, what are we looking at? And they had some really good basic stuff that I think helps. So I wanted to show you where I took these from. Okay, so yours is in black and white, but basically there is asexual and sexual reproduction. Most of the terminology we're going to deal with when we're looking under the microscope are a term in asexual production called conidias. They're reproductive structures, or that's how you identify them. And we're going to be looking for what are called micro and macro conidia. They're anywhere, the little ones, microconidia, look like little birds on what is called the hyphae, which is your mycelial element. It looks like stick-like structures. Sometimes they're septate and they're divided. Sometimes they're aseptate. They are not divided. But these reproductive structures grow off them. If they have large ones, they're called macroconidia. If they have little bird-like ones, they're called microconidia. So that's primarily what we're going to look for when we start looking. I put the lactophenyl cotton blue, which is the big stain used in fungus. That's a little thing of blue dye. And it's very, very pretty under the microscope. But I thought this was a good little sheet to show you some of the terminology without killing you. Okay? In picture form, too. So you have this on your sheet, and I must have did the back page 50 times trying to get it where you could read it, because trying to bend the book down. But the conidia they bud off it, and they are within asexual reproduction, and they follow mitosis. Okay? So that for us is what we're going to be looking for. So we are going to look, and many times they are budding directly off the hyphae. Some fungus will have structures called phyalids and conidiophores that are different cells. They say the phyalids are vase-like structures that produce conidia. Analides are ring structures that produce another type of conidia. So basically, we're going to be looking at the hyphae, and for sure at least small or large conidia. Some different fungus will have these vase-like structures. It would just depend on the fungus. So that's one term of asexual reproduction. So if you take away anything, if you hear the term conidia, it's asexual reproduction. Okay? When you get on the other side, there's a group that do sexual reproduction called the zygomycetes. And this is an example of sexual reproduction. Occurs by the fusion of compatible nuclei and subsequent production of a zygospore. So if you'd hear the term zygospore, that is sexual reproduction. And I have a sheet on one of my handouts that shows you the ones that are asexual versus sexual. Another example of asexual is arthroconidia. So it's a hyphae that breaks into multiple fragments on a hyphae. And that would be an example of asexual. So some of the terms I think are the hardest piece of fungus. What is that? Is that asexual reproduction? Is it sexual? Another picture I gave you was another example of asexual reproduction. They have spores that are produced called sporangiospores, and they have structures like columella and the sporangium that houses the sporangiospores. So we know conidia is asexual. We know anything with a sporangiospore is asexual. And we know, if you see here, a zygospore, that is sexual. Sexual follows meiosis. Asexual follows mitosis. So that, I just thought that sheet it gives you a little bit of an idea of terms when they start saying them when you read about them. So that was one sheet I wanted to give you. The next one is kind of what tests do you do, what media, and what techniques. And the page numbers I had to correct because that was from this Manucellus. So I'll tell you what they are in DeLost. And if you want to turn it over on the back side, this is what they are in DeLost, and this is what they are in Manucellus, my new one. So DeLost doesn't actually have a cellophane tape test, but my Manucellus still does. We're going to try it.
Do another one of that.
Anybody have an extra one? If not,
I printed one off.
if not, we can pass over.
I've got it right here because I was going to write the information down.
Yeah, just, and then I can always make another one. Okay. So if you want to take the time, DeLost at least has everything, and we're going to use these. You know, we're not. It was interesting. KOH was something we did when I was still at St. A's. So I'm wondering if they're getting away from it.
It's like the back of one of them.
Oh, it's my original. Someone have just the top of one?
Yeah.
Here, let me let everybody write these down, and then I will give you this one, Chris.
This one's the back and front.
Oh, yours. So it just would be Nicole that needs one. Who just had the back? Who just had the front? I thought someone said they did.
The front. He had it back there.
Oh. But you have one that is the back and front?
We both like it.
Okay. So it's interesting that the Scotch tape test that we're going to do isn't in DeLost, but it is in Manucellus. And the KOH, it's something you would add to see if there was possibly a fungus in like a vaginal specimen that you would do. But Manucellus doesn't have it anymore, which is interesting if everybody's getting away from it, because that's our latest textbook. That's like 2015. And I looked even in the index in the back, and they had no KOH, potassium hydroxide. So that's something we're going to do. We've already set up the slide culture, but we'll probably set up another one. But we're going to do the tease mount. You want to turn on that incinerator? I forgot. And you might have to make sure it's plugged in since you guys have been using the heaters in blood bank. We're going to do, we did the germ tube already, and we're going to do the Scotch tape test and the tease mount, and maybe set up some of our new stuff that's growing, because we have some really good stuff growing. Okay. So naturally, you're going to try to process it quickly if at all possible. If mailed, you want to add certain antibiotics to inhibit any bacteria from growing. Remember, if you're looking for fungus, you don't want any normal flora of the bacteria interfering. And you must note source of specimen and what's the possible disease. The bad ones are the dimorphics. So a lot of times it's going to be a long, maybe a sputum culture. The other one that's very common are the skin and hair and nails. They're called the dermatophytes. And there's only, the nice thing about that, there's only 3 genera. There's microsporum, trichophyton, and epidermophyton. So those are, the worst ones are going to be the dimorphic. So if you don't have any time to study something, study at least those. They're the most pathogenic. And then the other one would be, everybody has heard of athlete's foot, jock itch, that kind of thing. Those are the dermatophytes. So I think those, if you get exposed to something in a regular lab, they might do some kind of skin test of hair, nails, and your skin, the dermatophytes. So if you err on anything studying for your registry, at least study those 2 sets. So the blood, Candida albicans is probably our most common, and that is the main one. I have another paper that has a flow chart, and there is one that begins with a D that says produces a germ tube. I've never heard of it. I doubt if you'll see it. I think glabrata and that we had in class, and one called tropicalis. I've seen them. St. E's does a test for the other Candida besides albicans, and those 3 have been the ones they've done: albicans, tropicalis, and glabrata. Spinal fluid, I would expect, there are 2 that have to do with bird or pigeon droppings. One is histoplasma and one is cryptococcus, the one neoformans with the India ink we talked about. You would hope there would be something in the write-up about the patient, what they are exposed to, if you're going to suspect cryptococcus and histoplasma. Histoplasma would primarily be the lung compared to cryptococcus, though. So cutaneous, that's where you're going to do the nail, skin, hair. Something they also can use as an example of, something they can also use as an example if they truly have a dermatophyte is they call it a Woods lamp. They can look for fluorescence. Certain strains or species will fluoresce in the dermatophytes. So that's why it says a Woods lamp. That's looking for fluorescence. Respiratory, you're going to really worry about the dimorphics if you inhale it, and they're the most pathogenic. Remember, we already talked with Mycobacterium with TB. That has to be ordered for acid fast, okay? Under urine, I don't know, other than Candida yeast, how many they'll do for any other kind of fungus on a urine culture. Same thing with a vaginal or cervix. Candida albicans would probably be your first one, a yeast that you're going to consider. And we already talked about, when we get to gram-positive bacilli, we'll talk about nocardia. When we get around anaerobes, we're going to talk about actinomyces. There'll be a neat test that will know which way to go, if it's an aerobic or an anaerobic. So technically, you can do wet mount. We're going to do LCB. So that's what the LCB stands for. That's the most common stain. KOH, potassium hydroxide. We already know from just doing our gram stain on our practical, it's 2 to 3 times larger than bacteria, and they're usually gram-positive oval-shaped bodies. India ink is still a classic one you should at least know for Cryptococcus, and calcifluor white. If auramine was the fluorescent stain for Mycobacterium, then calcifluor white is the fluorescent stain for fungus. FITC was the fluorescent stain for Treponeme pallidum, which is a sexually transmitted disease. So think about what fits. If you know what fits, at least guide you to what organism you should be thinking. Okay, So that's the second thing I want you to add to your material. So